Bienvenidos, Ushamdi, and welcome to this Hut8 networking Techtorial on basic installation and configuration tasks for the ASA firewall. In this module, module number 5, we're now going to tackle for the first time our NAT configuration that's going to be required. Again, had we done the configure factory default, we would have had a NAT statement put in there for us, but we're starting from scratch and we've decided to use the CLI with no pre-configuration, and so we're going to have to add some network address translation in, but this is going to be a good topic to discuss objects, right? So there's two main types of objects with the Cisco ASA firewall. You have your network objects as well as service objects. So think of a network object as either a host, maybe it's a web server, right, where you're going to use that host's IP address and subnet mask. Or it could be a subnet, like the inside network. Maybe it's your DMZ network. And so everything that we're going to define with respect to NAT is going to require us to create objects because it's inside of the object definition where we're going to make those NAT definitions. Now, this is one of the reasons why right now we can't ping, right? I couldn't do HTTP and get access to anything on the outside. So if we take a step back here, so on this iMac, if I was to go to let's go to 209.165.200.254. So I'm going to try to access the HTTP services on that ISP router, which is on the outside network. So I hit enter, and you can see it's just going to hang here. Now, again, there's a couple things that are in play, one of which we tackle in this module, which is specifically the NAT. So what's happening right now is no NAT is configured. And so that router that I'm trying to get HTTP services from has no idea how to get to the hosts that are located on the inside network. In other words, it doesn't have any routing information to get to, and if you think about it, that's going to make sense, right? And so if we were to pull the pin tool up here, and this is actually going to make for a good whiteboard here. So here's my host on the inside, right? This is my Mac. And my IP is 10.0.0.11. And it's directly connected into this ASA 5505 firewall right here on this inside interface. Now remember, we said that by default, without any ACLs, that traffic is allowed to travel from an higher level security zone to a lower level security zone. And this is my outside, right? So the security level here is 100, the security level here is 0, and then here is that ISP router, right? And this is that 209 network that we have connecting us up here. Well, if traffic comes out to the ISP and I'm not doing any NAT and I'm using an RFC 1918 address, this traffic is not going to route on the internet. Again, we've got an easy case here where we're coming to a use case where we're simply trying to get to this ISP router that's directly connected to the ASA. But what if I was trying to get to something beyond that router? I have to NAT, and it has to be a publicly routable, in other words, a non-RFC 1918 address. So this 10 dot, that's going to cause issues, right? Not only does the ISP not know how to get back to that, but the ISP is probably filtering that. It's not going to route that traffic if it was bound for something beyond the ISP's router. And so that's where NAT, or network address translation, is going to come into play. Now, with the ASA, there are multiple, and I mean, I think 5 or 6 different ways that you can do NAT. You can do double NAT, you can do static NAT, we can do all kinds of NAT. We're going to be focused on NAT overload, right? Or port address translation, PAT, okay? So we're going to use that single IP address. Again, the use case is that this is a Verizon or this is a Comcast, right? It's some sort of a service provider. They're going to give you an RJ45 handoff. You're going to click, plug that right in to your ASA 5505 or 5510 or whatever the case may be in order to get connectivity. And so if you don't have a static address, right? We've got ours via DHCP. We're going to get a default route, but I'm going to show you how to do the default route. We're going to reconfigure the ASA a couple times. It's very quick because, again, we only have to change the interface VLAN 100 definition and assign a static IP. But again, there's a couple things that come into play here, but irrespective, right? So whether or not we have a DHCP IP address on this outside interface or a static IP address on this outside interface, we are going to use port address translation, which is going to allow everything on the inside to go out this interface with that single IP address. And we're simply going to be using ports in order to differentiate the connections, right? Just like it's again, they call it PAT, port address translation. And so that's what we're going to go ahead and set up. And so when we set the NAT configuration up, again, remember, it would work if we have a DHCP address, and it's going to work even if we have a static address. We have to make no changes to our network object and the NAT definition based off of whether this is static or DHCP. It's going to work both ways, and we're going to demonstrate both ways. So let's go ahead. Let's get on the command line and let's make this happen. So you could see here, right, that we couldn't access the HTTP services for the router, for the ISP router. Well, let's jump back onto the command line and let's make this happen. So here we are on ASA 512.01, right? This is the, whoops, and I apologize, looks like we still have the drawing tool up here. Let's clear the screen. All right, and there we go. So let's go from user exec to privilege exec. Cisco is our password, and here we are in privilege exec mode. So if I get into global config, remember I said everything is an object. Whoops, everything is an object. And so we're going to be focused on the network object, right? Because we're going to create an object that references the inside network. And so I would say object, network, and then I can do a name here up to 129 characters. Now 129 characters is probably a bit much. But again, at least you have 129 characters if you needed it. Now, this is something that you want to make sure that you have it stand out, right? So I typically go object, and then we'll say 192, oh, not 192, sorry, we're going to be 10.0.0.0. Now, you can't use the slash character. I wish you could, right? Because we could define it like that. But typically what I do is I'll put in the network mask or the prefix length here, right, with just simply another dash, and then inside net, right? So object 10.0.0.0/24, it's my inside network. And this is just simply the name, right, that if I was to refer to this later on, right, this is the name I would use to refer to this object. So now what can we do here in the object area? Well, I could put a description in here, right? Inside production network object. But if my name is good enough, I should be able to simply look at the name, right? But again, with the description, we can throw it in there. In fact, with the description, I could even come in here and say, and where is it going to give me? It's not going to let me recall that. So, oh, there we go. Production net, and I could say /24, right? So you could put the slash in there if you wanted to, because the description is kind of a free flow area, but always a good idea to put the description here. Now, if I was defining, maybe it's a web server object, right? Because maybe I've got 5 web servers. and I would do an object for each, right? And we're not going to discuss the object groups right now. So again, trying to describe if we were to create individual objects. So I could say host, and I would put in the IP address, right? And the network, the net mask of the host. But that's not what I want to do here. So I'm interested in a subnet, because again, we're defining the inside network. So I would say subnet 10.0.0.0 and then 255.255.255.0. So how do we see this? How do we confirm this? And this is also on the slide as well. I could simply say show run object. So here's a list of all the objects I have. And again, I get a great description there, right? Oh, inside production network. Okay. Right, I've got a really nice defined name for object 10.0.0.0/24 inside net, right? So this is my inside network object. Now, this becomes critical right here, and this is where you make the NAT definition. And I've called out, and we're going to digress here for just a second, back to the deck. So pre-8.3 releases. Remember, I talked about the significant differences between these pre-8.3 releases of code, and they had a different syntax. And specifically, it was different with NAT. And so that is how you would do the NAT definition when you had pre-8.3 code. You would say NAT inside and then the 1, right? And which would be your outside interface, which you would make your outside interface, and then you would put in the network. Now, with 8.3 code and later, you do it under the network object definition, right? At least in our case, the network object definition, if you were natting for a host, you would do it with the host. But here we're doing it under the network object definition for the subnet. And we simply say NAT from the inside network to the outside network, or from the inside interface to the outside interface. We're using dynamic NAT, and we're using the interface IP address. And again, that's kind of similar, right? Because you can define the interface when you're doing like on a router, right? You can define that you use the interface argument when you're making a NAT definition if you're doing PAT. Right? And it's the same thing here, right? So NAT from the inside interface that we've defined, again, remember, we named it inside. If we gave it a different name, like prod, it would be NAT prod, comma, outside. And the same thing, if we name the outside interface something different, it would be whatever those names of the interfaces are, that's the names that go here. And again, it's dynamic because it's dynamic NAT. And as soon as I say interface, it is port address translation, NAT overload, right? And so that's how we do the definition here. Again, if I go back to the command line and we take a look at this Cisco ASA, which I've actually downgraded to 82559, and I get into global config, and I say object, question mark, and you can see we can do a network object, and we'll just say, whoops, NAT object. And I come in here, you'll notice that what's the difference? Yeah, there's a description. There's a group object, a help, a network object, and a no, but what is there not in there, right? A lot of stuff you can see, but most importantly, it's the NAT statement. Right? And so this is the difference. So if you end up with whatever reason with a older version of code, and you like that older version of code, I highly recommend you upgrade, at least get into the 8.4 train, right? But if you can't, if this is what you're stuck with, remember that the NAT syntax is going to be different. In fact, since we're here, and let me try to see if I can do this. So you would say NAT inside 1, right? Because we're going to be referring to that outside interface, and then I would say 10.0.0.0 and 255.255.255.0. Again, this is if your network is a 10 network. And did I even screw that up? I did. Let's see what we've got going on here. Yeah, it should be. Oh, so Fortuitous failure. So why are we getting this error here? Right. I haven't configured anything on this ASA. So I would have to go, so we'll leave it at this. Because again, you should definitely get beyond 8.3 code. But that would be the statement. And then again, you would have you would do global outside, one interface for the outside, and you would say global outside one because that's what we're referring to here. So instead of saying inside to outside, you would define NAT inside, and then you would have the global outside, and whatever that global statement was, and it would look like this, right? If I said global, comma, or not comma, parents outside and one. So that number, that one, that's what we're referencing, right? And so that's how we're natting inside to outside. So it's a lot, you can see here, it's kind of kludgy, right? Because we're in two different locations. When we're with the most recent code, right, here's what that is going to look like. We're going to say nat inside, comma, outside, dynamic interface, right? So very, very straightforward, very, very simple. So now as soon as I hit enter here, and if I was to say show run object, you can see that's my object, right? If I was to say show run, and we'll come down here, you can see that we've got our object, but we also have, and did I already go past it? Nope, there it is. All right, you can see this network object here. We get this NAT, inside-outside dynamic interface, very similar to what we saw when we did the factory default installation. And so again, it's not in the object definition, right? Or it's not in that same segment of code that we see further up, right? Or the stanza higher up, but it is right here. And again, it's very simple to see that we're saying we want to do dynamic, or I should say NAT overload, port address translation, PAT, from the inside network to the outside network. And so now let's take a look at what we're going to see here. So if I go back to, whoops, let's cancel that out. If I come back here where it wasn't working before and I hit enter, take a look now, right? So now things are set up, and it's not gonna, I don't think it's gonna load anything. It's gonna come back and say unauthorized, that's fine. But we're able to access those HTTP services. So let's come back to the command line. And if I was to say show, not show Nate, show NAT, here's what we see right now, right? And it shows us the NAT statistics for this object that we created, that network object that we created. But more importantly, let me say show xlate, right? And so we can see, and we've got UDP PAT, and there it is right there, port address translation. We've got TCP PAT going from, and there's that host IP, the MAC that I am on right now, 10.0.0.11. We've got that random high port number to the outside interface, right? So what does the interface show IP address? What's our interface? And that is why you're seeing that 53 in here, right? And again, it shows us that that is the NAT that is being done. So we've taken care of the HTTP problem. How about, can I ping 209.165, 200.254, again, from the firewall? Yeah, it works great. So what about the host? So everything should be fixed, right? And you can tell by the way I'm saying that probably not. Not 254. I hit enter and take a look here. Yeah, well, this is odd, right? Because HTTP is working. How come ping isn't working? I've just proven that I can get to the HTTP services on the ISP router. I can ping the ISP router from the firewall, but I can't ping from this host, this iMac that I'm on. And that just doesn't make sense, right? Why is that not working? And so again, let's go ahead and say show xlate, right? You can see all of this traffic that's flowing, and there's this ICMPs. I was looking for an ICMP, and where was it at? Let me get a little further, or did I see ICMP? I thought I saw ICMP. Let me see if I say show xlate, include ICMP, or is it going to be case sensitive for me here, ICMP? No, I thought I saw ICMP in there. Sorry about that. So we say show xlate, right? And this shows me the connections running through the firewall that are being translated by that NAT translation. As you can see, we've got quite a bit going on. Again, if I say show NAT, there is a listing. It's going to show me the translated hits, the untranslated hits, and from inside to outside. So once again, show run object, right? So you create a network object for your inside network. You'll notice we don't have to do it for the outside network, just the inside network. And then show run, and I don't want the show run NAT, so let's say show run and begin NAT. And then inside that same network object is where we create that NAT inside to outside dynamic interface. And this is how you set it up, right, for port address translation. But we still have this one lingering issue, which is why can't I ping? Just doesn't seem to make sense. And that is what we're going to be tackling in an upcoming module. So at this point, again, as a quick review, if you've only done what we've shown in the first 6 modules here, you would literally be able to plug a host in with a static IP address that you've assigned to it on the inside of your network, and you'd be able to access the internet via HTTP, via TCP and UDP. You wouldn't have any issues at all. In other words, everything would work just like it would when the Verizon or Comcast router gets plugged in, and you don't really configure anything. You just kind of plug in, and again, you're going to get a DHCP address in that instance, and I've got a static IP here, but we're going to configure DHCP for the inside in one of the upcoming modules as well. So remember, I told you, and here are the configuration commands. We talked about the DHCP address, and again, remember that command that we said, show route. And you'll notice that I have a static route right here. But what if we didn't, right? We're getting that because we're getting a DHCP address, and I have set route set in the interface VLAN definition. But what if I did have a static IP with the service provider? So let's go into interface VLAN 100. And what if the service provider gave me IP address 209.165.200.200? Whoops, 255.0. So now, when I say show route, where is my static address? Where's my default route? Right? It's not there because I'm no longer automagically having it put into the routing table here on the ASA because we don't have that IP address DHCP set route statement. So if you have a static address from your provider, you're going to have to put a static default route definition on the ASA. And so what I would say is route outside, and it's similar to iOS, right? So I would say route outside, quad zeros, and then the next hop IP, 209.65.200.254. So I would have to do that to make sure that I've got a static route in here. And so now from the inside, right, let's go back to the browser, let's cancel that, and let me reload. It still works. Again, if I pull it out, if I take that static route out, and I come back here, whoops, sorry, I don't want to do that. We want to go, and I come back here and I do a reload, and actually that might be holding on to the translation. Give me a second here. Let's say clear xlate and clear nat, and we'll get, oh, I don't get rid of the counters. Whoops. Okay, so because that should not be functioning right now, although it's continuing to function. It should it? No, it should not. Because actually it is, because it's natting to the outside interface. I apologize. So that is going to continue to work because we're natting to the directly connected IP address, so it would work. I was thinking to myself there for a second that if we pulled the default route out, so here's what wouldn't work. Better example. I've got a loopback address set up to sort of mimic the Google DNS server of 8888. So if I ping out to that 8888, you can see it's going to say no route to host, right? Because I don't have a default route. There's no information here. Get an updated look here. There's no information here on how to get to the 8888. I don't have a more specific longer match, so I would have to have either a more specific longer match to that 8888, or we would need the default route. So again, this is a better example. I apologize for that HTTP there. That is going to work because it's going to NAT it to the directly connected outside interface. I wasn't thinking big picture there. So let's put the static route back in. And then let's do that ping command again. And now it's going to work. And so again, in a typical scenario, you need to have this route outside. If you've got a static IP assigned to that VLAN, that SVI interface, you're inside and outside, you have to have this default static defined, or else you're not going to get connectivity. In this case here, remember, I'm directly connected in, and I'm trying to attach, right, or get HTTP services from something that I have routing information for. But if I was trying to, go to the 8888, for instance, right, up here, if I said 8.8.8.8, right, it works now. But if I pull the default route out one more time, and we come back over here, it's not going to work, right? And so I probably should have used that 8888 address. Again, I apologize if there's any confusion there, but to be clear, the reason it worked with no default route is because it's natting it to the directly connected network, this 209.165, so the router, right, or the ASA knows how to get to where it's going. But when we pull that default static route off and I go to something I'm not directly connected to and that I have no routing information for, it doesn't work. So again, fortuitous failure there. But if you're doing a static, you put your static in that interface VLAN SVI definition. You define a static default route pointing to the next hop IP address, in other words, your ISP, and off you go. If you have DHCP, you've got that set route in there, and you are golden in both cases. All right, so to recap, we talked about the two types of objects that we're interested in right now, the network object and the service object. We configured a network object for the inside network, and that's inside that object definition where we put the NAT statement so that we have natting capabilities and we NAT everything on that inside network to the outside interface IP address, and we use port address translation in order to allow thousands, tens of thousands of inside hosts to get internet access, right? And simply the ports will be used to differentiate those connections. We looked at how we can validate and see that we've got translations happening, how we can see the objects, how we can see the NAT that is set up, right? And so at this point, HTTP is working, it's working great, but ping is still not working. And so we're going to be covering that in one of the upcoming modules where we get into that modular policy framework. All right, so thank you so much for watching. At this point, you've got HTTP, you've got everything going on your ASA, and you can actually use it to connect to the internet and browse the web. You can do all kinds of other things too, but we cannot ping yet. All right, thanks for watching. I hope to see you in Module 6.